Hey everyone, and welcome. So today, we're going to talk about Agentic AI. These are the systems designed to act for us, to get things done. But as we start giving them more and more power to make these huge autonomous decisions, we hit a really critical question. How do we actually build them in a way that we can trust their judgment?
All right, let's get right into it. The star player in this whole game, of course, is the large language model. LLMs are the engine driving this whole new wave of AI. But, and this is a big but, when you talk about making the kind of consistent, high-stakes decisions that a business absolutely depends on, well, LLMs have a pretty serious problem.
And this is where you can see the issue laid out plain and simple. It's just a fundamental mismatch. For those decisions that really matter, you need things to be ruthlessly consistent, totally transparent, and you need to be able to adapt on a dime. LLMs, with their built-in randomness and their black box nature, are pretty much the exact opposite of what you need for that job.
So let's dig a little deeper here. Let's break down exactly why using an LLM as your main decision maker is frankly a really risky proposition for any serious business.
So here's the bottom line. The very creativity that makes LLMs so incredible for brainstorming ideas becomes a massive liability in a business setting. And that black box problem? Could you imagine telling a regulator, oh, don't worry, the decision was made by this black box, and then it was explained to us by another black box? Yeah, that's just not going to fly, is it?
So if LLMs aren't the right tool for making that final, critical call, then what is? Well, the answer isn't some brand new futuristic technology. It's actually a well-established one that was designed from the ground up for exactly this kind of high-stakes automation. And this quote right here, it nails a core principle of good system design. Your decision agents should just decide. That's it. They shouldn't do anything. This makes them stateless. And why does that matter? Because it means you can reuse that same piece of decision logic, like checking a customer's eligibility, in tons of different processes. It's super efficient.
The answer is something called a decision platform. And again, this isn't a flashy new toy. It's a robust software system that's been used for decades to automate critical business decisions by focusing on clear, explicit rules and logic.
And this is what's so great about it. Remember all those problems we saw with LLMs? Well, a decision platform basically solves every single one. Instead of randomness, you get absolute consistency. Instead of a black box, you get total transparency. And instead of slow, expensive retraining, you get real agility to change the rules whenever the business needs to. And this isn't just an idea. It's a professional, structured process. The logic is created, stored in one central place. It's validated for errors. You can even simulate changes to see the business impact before you go live, and then it's deployed as a reliable, reusable agent. This is how you build an enterprise-grade system you can actually count on.
But, hold on, business decisions are not always black and white, are they? Sometimes you have to deal with probability, with uncertainty, and this is where we need to bring in another specialist for our AI team.
This slide just breaks it down perfectly. Our decision platform handles the prescriptive logic. That's the what should we do based on the rules we've set. Machine learning models, on the other hand, handle the probabilistic logic, the what is likely to happen based on all the patterns in our historical data.
And this isn't just theory, right? This is happening all the time. Machine learning agents are constantly crunching data to produce scores for things like fraud likelihood or credit risk. And those probabilities become crucial inputs that we then feed into our main decision agent.
Okay, I know this can all sound a little abstract. We've talked about a lot of different pieces. So let's make it tangible. Let's walk through a real-world example, a bank loan, to see how this whole team of AI agents actually works together.
So our story starts simply. A customer wants a loan to buy a boat. They fill out the standard application, but they also hand over an unstructured document, a brochure for the boat itself. And this is where our AI team gets to work. And here it is, the whole team in action. Think of it like an orchestra. And notice, the LLM isn't the star soloist making the final call. No way. Instead, it plays two critical support roles. First, as an ingestion agent to read the brochure, and second, as an explanation agent to translate the final result into plain English. The heavy lifting, the analysis, and the actual decision, that's all handled by the specialists, the ML models, and the decision platform.
So in this one smart, transparent, and totally audible process, you have three distinct AI technologies. Each one is playing to its unique strengths, and they're all working together to get a reliable business outcome.
Now, a system that can't learn and improve is basically destined to become obsolete, right? So how does this team of agents actually get better over time?
And this is a really crucial point. Learning happens differently for each agent. The ML agents can learn automatically from new data to improve their predictive accuracy. But the decision agent, it absolutely does not learn on its own. That would violate the whole principle of consistency. Instead, it's improved deliberately by business experts who run controlled experiments, like A/B tests, to optimize for better business outcomes.
And this is the final vital piece of the puzzle. True, system-wide improvement isn't automatic. It requires a thoughtful, big-picture process. You can't just let the individual parts learn in isolation. Someone has to own the entire framework and systematically learn from the overall results over time.
So what's the future of enterprise AI? Is it a single, giant know-it-all model, or is it a team of specialized agents working together? The big takeaway here is that building powerful, reliable systems isn't about finding one superintelligent model. It's about being the conductor of a well-tuned orchestra, making sure every instrument plays its part perfectly. The real intelligence, it turns out, is in the design of the system itself.